today we'll start our class. Today's topic is mostly about moment of inertia calculations, and we'll go through the some of the questions of previous year lectures. Okay, so first question is not about related to moment of inertia. It is something else. So let's say that consider a compound scattering of X-ray by carbon block. The wavelength of the incident ray, so incident wavelength is 0.1 nanometer. The scattered radiation is viewed at an angle, so the scattered radiation viewed at right angles to the direction of incident beam, so 90 degrees is the scattered angle. What is the Compton shift, what is the Compton shift of the wavelength due to scattered ray? So Compton shift is calculated by, so lambda prime minus lambda, so whatever is incident and whatever is scattered, and it is given by h by mec into 1 minus cos theta. So this theta is the same angle as we viewed. H is the Planck's constant, h is the Planck's constant, and mass of electron and speed of light. So this part, so this part has a value 0.00243 nanometer, and 1 minus cos 90 is 0, so answer is 0.0024 nanometer. So this is the correct answer. Okay. So consider a solid object moving through a fluid. From dimensional analysis, we have to tell the drag force by the fluid on the speed of v. The object is proportional to v square 1 by v. So we have to calculate the drag force and v. So proportional to what? This is the question. So consider a solid object. Let's say this is the fluid we have now on solid object. If it is false like this, what is the let's find out what are the dependencies. So force drag should be proportional to the density of the fluid, right? So if the higher the density, then higher the drag force will be, or so it will be proportional to rho, and let's say the dependency we take as a. So we know already that a should be greater than 1, but let's start with a generalized formulation. So we have to, because we have to do a dimensional analysis, and we don't priori know what the dependency on v is. Okay, now another so let's say v to the power b. So the velocity of this is v, and let's say the drag force depends on some v to the power b, and another thing it can depend on, it is the area. So area and the contact. So the more the contact area or the less the contact area, the drag force should change. So area to the power c, let's say. Now this dimension of this drag force should be equals dimension of rho to the power a times dimension of v to the power b times dimension of a to the power c. So from we already know that the dimension of force is mass ml t to the power minus 2, ml t to the power minus 2. Okay, this is the dimension of force. So what is the dimension of density? Mass per volume, this whole thing to the power a, right? Dimension of velocity is L t to the power minus 1, so this whole thing to the power b. Okay, and area is L square to the power c. So let's calculate the right hand side. So we get m to the power a, L to the power minus 3a plus b plus 2c and t to the power minus b. And we in the left hand side we have l ml to the power minus 2. So if we compare, so a becomes 1, l in l we have minus 3a plus b plus 2c is equals 1, and minus b equals minus 2. So b equals 2. This is all what we need to solve this. So if b is equal to, the force of drag is proportional to v square. This is the answer. So drag force proportional, it becomes proportional to v square. So this is the correct answer. So this is some basic questions, just to generic questions, not related to moment of inertia, measurements or anything. We'll come to that. These are given in the assignment, that's why we are doing it. So, okay, so next question is about moment of inertia. Okay. There are some technical issues. Hello. 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 Okay. Let's go. Okay. So from a uniform disk of radius r, a small disk of radius r by 2, from a uniform disk of radius r, small disk of radius r by 2 is cut and removed. So this part has been removed. So the position of the remaining shaded portion of the would be, so from the symmetry we can tell that initially, so the center of mass is at the middle. So let's take this middle. So let's make and an coordinate xy, and let's take this as origin. Okay, so initially the center of mass is at 0. Now we have to tell the where will it shift and how much it will shift. So we know that center of mass formula is at x in one direction, xi mi by sum over I mi. So mass, moment of mass, so this part is moment of mass, that is location at that mass, sum of I of all of them, and divided by the sum of all the masses. This is how we calculate moment of inertia. So x, now center of mass nu would be the old mass and old position plus the mass removed at how much time. So let's write it, mass removed at location, at what location, and mass old plus mass removed. Okay, so this will be m at old position was 0 0, so it is 0, plus mass removed is minus m amount, and how much radius it was removed, it is r by 2, divided by old mass plus mass removed is minus m. Okay, so what we get is minus mr by 2 times capital M minus small m. So this is the new mass. Now we have to find out how this capital M and small m are related. Now one thing we know from a disk, for a disk, so mass is proportional to r square. Why? Because the like pi r square is its area, and whatever mass is there, it is distributed over this area, so mass will be proportional to r square. Now small m, the amount of removed, is proportional to r by 2 square, so which is equals r square by 4. So small m by capital M is 4, no, 1 by 4, sorry. So capital M is equals 4 small m. So from here we can put this 2 into 4m minus m, so 3m, so minus r by 6. So this is xcm new. So what does it mean? It means this moment of inertia, this center of mass will be shifted towards left with amount of r by 6 amount distance, it will center toward left. So the correct answer is r by 6 to the left from the center of the disk. This is the correct answer. Fine. Okay, next question is, we have given 3 structures. Accompanying figure shows that rigid composite body made up by welding a circular disc. We have welded a circular disc of mass 2 kg, a round shaft. So this is the circular disc. Okay, a round shaft of mass 1.5 kg. So I think this is the round shaft of mass 1.5 kg, and length is 180 millimeter, and a square plate, and square plate like this of mass 1 kg. So we have mass circular is 2 kg, a round shaft, so mass of shaft is 1.5 kg, and length of shaft is 180 millimeter, and a square plate mass of square is 1 kg. Assume these all parts have the same uniform density, the same material. Determine the z coordinate of the center of mass in the system given. So one thing we notice that this is our origin, so these are our coordinate systems. So this is x, this is y, and this is z. So this is 0 0 0, and this is the length ls, which is 180 millimeter. Now we have to calculate the center of mass. So xcm, we all know that moment of mass by sum over all the masses. So how many objects we have? We have 3 objects and 3 masses. So mass of C first. So mass of C is mc times what is the location? Its location is 0, plus then comes mass of shaft, I guess, mass of shaft, and ms and its location. So this whole thing is has a center of mass. Because of the symmetry, we assume them at the center. So this whole length is ls, so ls by 2 will be the location, plus this is that is m square times what is the location of the square? This is just this ls, so ls will be here, and mc plus ms plus m square. So this, if you calculate, ms is 2 kg times ls by 2, which is 90 millimeter, plus m square is 1 kg times 180 millimeter by 2 kg. So sorry, here we have kg plus ms is 1.5 kg plus 1 kg. So first one is 180 or 360 by 4.5 millimeter. This will give us 360 divided by 4.5 is 77, but I think I made some sorry, here it is 1.5 and 1, yes, so this is not 360. So 90 times 1.5 is 135 plus 180 is 315. So 315 divided by 4.5, we get 70 millimeter. So this is our answer. This 70 millimeter is our answer. Okay, easy question. I'll show for some time. Hello. 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 Okay, so we have already started at 3. If you can hear me, please let me know. And we have already solved 3 4 problems from previous year. It is mostly easy problems. One is about Compton scattering where you are asked to calculate the Compton shift in wavelength. So this is the formula it was given, and you get this answer. Next was you are asked the drag force of a solid object falling under gravity and inside a fluid, and what is the flow drag force would be dependent. So from a dimensional analysis we did find that so we took density, velocity of the object and area, and this is how we did the dimensional analysis, and we found out that the drag force should be proportional to v square. Next is we were asked uniform disk was there with radius r. A small portion has been cut out. Where will the center of mass will shift? So we used this center of mass equation, and we found out that it will shift towards left about by 6 amount. One important thing to note here is the disk's mass is proportional to r square. Why? Because it's pi r square, and so the pi r square is the area of the disk, and the mass is distributed over the area, so mass will be proportional to r square. So if we remove small m amount of mass, it will have r square by 4 amount of proportionality towards area. Okay, so I hope you can hear me. So next question. Next question was we are given this kind of setup where we have a disk like this, so with some mass, and a cylinder like this with some mass and length, and a box, square box like this, so square plate of like this, and with some mass given. We are asked to find out the moment of inertia, so we use this moment of inertia. So my xi by sum over I mi. So and we just use mass, so every mass times its location, mass times location, mass times location divided by sum over the masses, and we found 70 millimeter from the base is the total moment of center of mass of the system. 70 millimeter from the base. Okay, so we'll go to the next problem. So the next problem is a cylinder sector of radius r. So it is a circular sector of radius r. So this is a section of a circle, and radius r has uniform density and subtends an angle theta at the center of the curvature. So it has an angle theta at the center of the curvature. So this whole angle is theta. Okay, choose x-axis so that the object is symmetrical about the x-axis. So this is the x-axis chosen so that the object is symmetrical around it. By symmetry, its center of mass should be located at x-axis. The distance of the center of the mass from the origin O is equal to, so you have to find the center of the mass from the distance. Okay, so center of the mass, so till now we have all xcm we have already discussed, which is sum over I mi xi by sum over I mi. So we can write it in a continuum setup is x dm by integral dm, right? So we can, in a continuous mass distribution, we can write it like this. So whatever the location of it, times the mass per unit length by total mass. Now let's assume that mass per unit area is given and which is equal to sigma. Then we can write dm equals sigma times dA. For a small area dA, so let's use some brighter color. So small area like this, sorry, let's use so this is, let's say, dA, and in this dA we have sigma mass per unit area. Now then we can write xcm as integral x sigma dA divided by sigma dA. So sigma, if it is constant density, uniform density, then we have integral x dA by integral dA. So we will calculate both of them. So what is integral dA? So we know that dA is the area element, and for a circular disc the area element is r dr d phi. So let's say this is now, let's say this is r, sorry, so let's so this is the area element, okay, in 2D, in, sorry, it should be in 2D. So let's say this is r, this small portion is dr, and this angle is d theta or d phi. So this area will be r dr d phi. So this area will be dr d phi, and to calculate the whole area from here, and we need to integrate the area element becomes, sorry, the area element, this area covered by the whole disk will be r dr d phi. Yes, the area element is r dr d phi, not the whole, this part. Now to calculate the whole area for integral dA, we integrate it r dr d phi from some r, in some r some d phi. What is the r? Here we have given from 0 to r, 0 to capital R. So the area will be 0 to capital R, and d phi will be, this is minus theta by 2 to theta by 2. So we take clockwise anti-clockwise as positive angle and clockwise as negative angle. So minus theta by 2 to theta by 2. So we get 0 to r dr minus theta by 2 to theta by 2 d phi. So what we get is r square by 2, 0 to r phi theta by 2 to theta by 2. So we get half r square theta by 2 plus theta by 2. So half r square theta. So we get this part. Now we have to calculate the numerator part. So this part. So we got the denominator, this, and we need to, let's calculate the numerator part. So what is the numerator? It is integral x dA. So we can write for a circular setup x equal to r cos phi. Okay, x equal to r cos theta or equal to r sin theta in that sense. So it is r cos phi. Same way we have r dr d phi, and we have two integrals. So now we have r squared dr integral cos phi d phi. So r square integral goes from 0 to r, phi integral goes to minus theta by 2 to theta by 2. So 1/3 r cube 0 to r, and we have sin phi minus theta by 2 to theta by 2. So sorry, so we get r cube by 3 sin theta by 2 minus sine of minus theta by 2. Fine. So what we get is r cube by 3. We know the sine is an odd function, so minus theta by 2 is theta by 2, so we get 2 sine theta by 2. So we get 2/3 r cube sine theta by 2. So the center of mass was this integral. So this integral divided by this integral. So this integral's result is this. So xcm would be 2/3 r cube sine theta by 2 divided by that integral half r square theta. So divided by half r square theta. So we get 4/3 r sine theta by 2 by theta. This is what we get. So let's look at the result. So 4/3 r sine theta by 2 by theta. This is the correct answer. Okay. So let's go through one more time. We know this center of mass to be given by this, and so we transform it to a continuum setup where we have x times dm integral by integral dm. Now mass per unit area we assume to be sigma, so dm equals sigma dA. So we replace dm's here with sigma dA, and because it is given that the uniform density, so sigma is constant, so we get sigma cancels, so we get x dA by dA. So these two we have trying to find out. So dA is given by r dr d phi. So we integrate r dr d phi and we get this. Then x dx is r cos phi and r dr d phi, and we integrate like this and get this, and we divide these two and to find out the answer. Sorry. Okay. So next question is, consider planar body. Denote the plane of the object as the xy plane. So let's draw the axis. So we are already at question number 6. You will be, whoever is joining now, you can go back to the video, or you can go you can look at this PDF will be shared. So we are asked that there is a planar body. Let's say these are the axes x, y and z axis, and the object of the plane is the xy plane. So object is at xy plane. So this is, let's say, the object. Sorry. Yes, let's say this is the object. It is an xy plane. So you are asked if two perpendicular axes are chosen as the x and y axis respectively, such that the moment of inertia. So the moment of inertia about y axis is double that of x axis. So y is the moment of inertia about y axis is double that moment of inertia about x axis. So this is given. No, sorry, ixx is the double than twice of iyy. Okay, moment of inertia about the y axis will be xx. Fine. Yeah, the moment of inertia about an axis perpendicular to the plane and passing through the moment of inertia about an axis perpendicular to the plane and passing through the intersection of xy is 9 kg per meter square. So basically they are saying, so whatever perpendicular to this axis, so you see this line is proportional to z. So we can say the izz equals 9 kg meter square. Find the value of ixx and yy. So from the perpendicular axis theorem, so we know from the perpendicular axis theorem, izz equals ixx plus iyy. So we already know ixx equals 2iyy. So 2iyy plus iyy equals izz. So 3iyy equals izz is given 9 kg per meter square. So 9 kg not per meter square, kg meter square. So iyy equals 3 kg meter square. So ixx will be double of this, so 6 kg meter square. This is our answer. So what is it given? So ixx we got 6, iyy we got 3. 6 iyy 3. Okay. ixx we got 6 and iyy we got 3. This is the right answer. Okay. Okay, let's go to the next question. So next question, determine by direct integration. By direct integration, the moment of inertia of the shaded area. So this shaded area is given as shown in the figure with respect to y-axis. With respect to, take the surface mass density to be 1. So Iy with the moment of inertia with respect to y-axis is simply integral x square dA, right? It is x square dA. So let's calculate. Fine. So what is given? This equation of this curve is given, which is y equals kx minus a whole square. Okay, and this area element will be, so this will be y dx. So for iy, for in the if we take care of the change in the y direction only, so we can write it as y dx. So integral x square y dx. Fine. So now this y is equals, it is given from here, so k x minus a whole square times dx. Okay, and so the so integral will be on x, and x from 0 to a, so 0 to a, so we have k integral 0 to a x square times x minus a whole square dx. So let's calculate this integral. X square times x square minus 2ax plus a square dx. K times 0 to a x to the power 4 minus 2ax cube plus a square x square dx, which is equals k x to the power 5 by 5 minus 2a x to the power 4 by 4 plus a square x cube by 3 0 to a, which is equals k a to the power 5 by 5 minus a by 2 a to the power so half a to the power 4 times a, which is a to the power 5 plus 1/3 a square times a cube, which is a to the power 5. So k a to the power 5 1/5 minus half plus 1/3. Okay, so we get 130, 1 by 30, so k a to the power 5 by 30. Okay, so this is y. Now if you look at the questions, it is given in terms of a and b, no k is there. So how do we calculate k? So you already know that y equals kx minus a whole square. Now at y equals b, at x equals 0, we have y equals b. So let's put it. So x equals 0, y equal to b, k a square. So k equals b by a square. So iy becomes b by a square a to the power 5 by 30, which is b a cube by 30. So answer is b a cube by 30. This is the correct answer. So look at this. You can ask questions if you have any doubt in the chat or in unmute by unmuting yourself. Okay, what are you asking? Step 2, step one more time. Step 2. So you understand this, I guess. So this is how the um, this is how moment of inertia along y-axis is defined. It is x squared times dA. dA is the area element. So we write the area element as y dx. So it is basically, so you take a small area here, which is actually dx dy. Okay. Now you integrate over full y, so you get y dx. Okay. So this is the area element. Now this is y dx and x squared dy. Now this y is given the y is given as this equation. So this curve, you see, this curve is y equal k into x minus a whole square. Okay. So y equals k into x minus a whole square. So that is what we have put here, and then we take k out and do this integration. Was it does it clear it out? You can write in the chat. Okay, so we'll go towards the next question. It is the last question. So it's a similar problem, and it is given that determine the moment of inertia ix and iy of the circular sector shown in figure about x and y axis respectively. So I have to find out ix and iy. So it's similar to the last problem. So ix is y square dA and iy is x square dA. Okay, now it is a circular disc. It's a part of a circle. So for circle we already have seen that the area element is in polar coordinates. This is area element in polar coordinates. Okay, this is area element for r, dr and d phi. D phi is any angle here like this. This is dr, this is r and this is d phi. Okay, now let's calculate. And also for a circle we can write, so let's say for a circle if you have a point x comma y here which is defined by phi and r, so you can write x equals r cos phi, y equals r sin phi. Okay, okay, so let's, the rest is very easy. Hold on a minute. Oops, I forgot to add a page here. Fine, so let's calculate. Now look at this. Let's calculate ix. So ix is x square dA. So x is r cos phi. So r cos phi whole square dA is r dr d phi. So we get integral r square and another r, this which is r cube dr cos phi d phi. Okay, now what is the r limit? So it should be from 0 to capital R. So 0 to capital R, and cos phi d phi is minus theta by 2 to theta by, no sorry, minus theta to theta. So minus theta to plus theta, sorry, cos square phi. So I guess you know how to integrate cos square phi. So this part is r to the power 4 by 4. Okay, times cos square phi we write like this d phi. So cos square phi 1 minus sorry, this is iy basically. Iy is x squared there, yes. So we write 2 cos square phi is 1 minus cos 2 phi, right? No, sorry, 1 plus cos 2 phi is 2 cos square theta by 2. So this is integral minus theta to theta d phi. So r to the power 4 by 4 times half phi plus sin 2 phi by 2 minus theta to theta, which is r to the power 4 by 8 theta plus sin 2 theta by 2 minus theta minus sin 2 theta by 2. which gives you r to the power 4 by 8 2 theta plus sine 2 theta. So if you take 2 common, r to the power 4 by 4, this is iy theta plus half sine 2 theta. This is what we get as iy. Okay, now for ix you get y square dA. So y is r sine phi, so r square sine square phi, dA is r dr d phi. Same thing, r cube d phi, sorry, r cube dr 0 to r sine square phi d phi minus theta to plus theta. So I think you can, in the same way it has shown, you can integrate this and you will finally get, so you can check, it will be the same thing with a negative sign. So r to the power 4 by 4 theta minus half sine theta by half sine 2 theta. So for I, this is ix, so ix has plus, ix has negative sign and iy has positive sign. So this is the answer. I guess you can do this integral at the same way I have shown in for the first integration. Any questions? Questions or doubts or anything? I guess not. Then fine. Thank you for joining. You can go through these lectures one more time. Again, you can go through this video. Okay. Thank you. Thank you for joining.